Hey guys, this is Eric Weingartner with Weingartner Racing. It's been a busy week. That's the reason why I haven't had a chance to get out a video, like super busy. So for instance, on Monday was supposed to be my son's graduation from high school, but because of the bad weather, they moved it to Tuesday. Tuesday he graduated. I'm super proud of him. It was a terrific day. But it was made the whole day, of course, busy, but well worth it. Anyway, so he graduated high school. And then on Wednesday was a normal day working, but I was trying to get a job done because on Thursday, and that's the part you're probably watching the video for, is I was dynoing an engine because I had to go to Dunsworth to drop off two different sets of heads for different customers. One of those engines is a 327 that will be dynoed later on, and it'll probably end up on the channel. But I had to drop off heads for that, and then a 598 big block Chevy. But since I was there, I decided I would dyno this engine. And this particular video that you're watching, it's going to be a little bit of tech, and the warning, my editing sucks on this one because I'm not wasting time on that today. I just ain't got time for it. But we're going to see the power difference between a mechanical water pump and an electric water pump. It will shock you. But let me go ahead and show you the engine and why it got dynoed and just show you other stuff that's going around. So besides doing just this dyno thing, I'm going to show you the other things going on in the shop and things that are going on. Kind of like an update, but also some tech. This is the engine that got dyno tested. This is my Circle Track Dyno Mule engine. What it is, it's a 414 small block Chevy. I'm gonna give you a little bit of history lesson on this. So probably 5 years ago, this particular customer, he ordered the short block from Mullins. So he ordered a Mullins short block, which was a Dart little M block. I believe it had Maul dome pistons, Callie's Compstar rods, and crank. And he had me do the top end, and also, by the way, had a Mullins cam, whatever that was. But he had me do the rest of the engine, so do the heads, the intake, and then we went and dynoed it. So these heads are my Dragon Slayers, but these are, you can even tell the year on them. Looks like they got wiped out. Nope, it's right there, 2020. So yeah, it has been 5 years. These are 242 cc's. They have a 210 intake valve, 1/600 exhaust valve. I hand ported these. I hand ported so many of the Dragon Slayers, but this is one. This is a Holley 300 110 that I ported as well. The initial dyno testing whenever we did this, the very first time at Dunsworth, it made 697 and like 592 torque. So it was a pretty good running deal. They put it in their IMCA modified. It's an A mod, not a B mod. And they went out and ran, did really, really well. Won, I think, about 4 or 5 races with it. But anyway, one particular night that was just smoking. It was smoking real bad, and they were a little bit concerned. So they did a little leak down and looked at a cylinder, and it had a really bad leak down on one of the cylinders. They pulled the head off, and it turned out it had cracked the piston right across the top of the piston. So luckily, it was probably just like 1 or 2 laps from just the whole piston letting go, because it was just cracked across the top. But it could have broke all the way, and then we'd have a pile of scrap. So anyway, they sent it off to a different company. So I don't build engines anymore because I just don't have time. It's not that I can't, I just don't have time. So they sent it off to a different company, and they did a fine job, except for elusive, like many companies, they're like, the customer dropped it off and said, hey, let me have the heads. I'm going to get them rebuilt by Eric since he did them initially, and then give them back to you. And this company, like many engine builders, are like, nope. Either we do the whole thing or we don't do it all. I don't want to be reliable for someone else's work, which I respect. But also, if you don't do what I do, you can't do this. So, and I contacted them. I said, hey, just because I didn't want this to happen, and I kind of figured this might. I didn't tell them my whole valve job profiles. I keep secret because they're custom to me. And I spent a lot of money and research just to get them right. And they match the heads. You can't just put on, even though it's a 50-degree valve job, you can't just go grab one from Goodson and put it on. Anyway, I told them, use this top cut if you have a cutter that's for it, and hoping they would at least get kind of close. No idea. Anyway, they put it all back together. They redynoed it at their place and made 650. And I was like, well, maybe, just maybe, and I can't guarantee it, maybe their dyno reads lower than Dunsworth. Even though in my mind I'm going to know, I've been on Dunsworth dyno, and anybody that says, man, that dyno's high, come to Dunsworth. Get humbled soon. Because I've had several people say that, and every time they're down. Look, I've been in many dynos across the entire country, and the Engine Masters several times. There's only been one time in Engine Masters where it made less horsepower. It made one less. Most of the time it was up 30, 50, sometimes 60 horsepower up from what Dunsworth was. So, no, his dyno reads low, but maybe this guy's would read low. lower than Dunsworth. Maybe that's a possibility. And it made 650, so I was like, that's really low. Anyway, they put it back in the car, and they're like, man, yeah, it's for sure slower. And this has been about 2 years ago. Anyway, the team itself had a falling out, nothing to do with the engine itself, and they just kind of parted ways, and the engine's been sitting for about 1.5 years. And the guy, I told him whenever my mule broke, I was like, do you have that so I could do some testing? He's like, yeah, I do, but I'm just trying to sell it. Well, anyway, flash forward a few weeks ago, I gave him a ring, or just a ring to talk. He's like, you should come get that motor. So I did, and we re-dynoed it this week. So long story to tell you, that's the reason why I got re-dynoed. And guess what? It made 654 horsepower. It's down. It's down 50 horsepower from what it was before, 47 to be exact. But yeah, it's down. It's confirmed. Their dyno reads the same as what Dunsworth does, and it's down 47 horsepower. So whatever they did, it definitely reduced power. But because this was on the dyno, I thought, well, we'll just test a few things. So what all got tested? Well, obviously it had a mechanical water pump on. This one. And it's a nice water pump. This is what they use in the circle track. It's a nice water pump. It's made by Edelbrock, and it's a high flow unit. And you could tell by the pulley setup that's here and the one you just saw on the engine. They do it this way because they're turning 7,800 RPM, and to not overspeed the water pump, this is the pulley setup they work with. So it's shouldn't be a huge draw or nothing like that. Plus I've got the side exits that cools. Anyway, one of the first tests that I did was determining how much power this actually lost. So I removed this, put on an electric water pump, and you can put in the comments how much power you think this actually cost. So I won't spare you a whole lot of suspense, but here's what difference in power made. Here's the difference in power. So the red line being the mechanical water pump, and the black line being the electric water pump. And if you look at the graph, they're not that far off. So again, the black's the electric. So in the beginning, so we really start about 4,000. They're pretty much tracking each other. There's no huge difference there. Oddly enough, between the middle, so this is probably where the pump is actually starting to make some draw, just in that RPM range. It's a little bit down, but not bad. But even at peak, that's where it's off a little bit. But that difference was about, if I remember right, 3 horsepower. So this pump, and I would have thought 20, because I thought maybe the reason why it made less power this time is because maybe they dynoed it with a mechanical water pump on, and that's the reason for the loss in power. No, it was only worth 3. So for those guys that are like, man, I really want to go faster, but I've got this, mechanical water pump and it works great, and all my belts and everything line up with it, but I could be getting so much faster if I put electric water pump on. Not really. Not according to my test, and not with this pump. Now, maybe if I'd done it with, say, a stock pump or a stock replacement pump, this might have been a different story. But in this configuration, which these are not cheap pumps, I know that, this did not eat power like you would expect. So there's that part, but I also tested other stuff as well. But I'll show you this real quick just for fun. This is the difference in power between before and after. So the black line, 697 horsepower, that's what it did before when I first did it, 592 foot-pounds of torque. The red line is now. They knocked off that much power. That's huge. So I'm going to check the cam. This was a Mullins custom cam, at least when I put it together. I don't know if they changed cams or something, but it's not that. Oddly enough, you can look at some other things too. This is before and after. This is the airflow. So the black one was what it pulled for air before, 794 CFM. It don't pull that now. But oddly enough, it pulls more fuel now. It takes more fuel to make that power. And by the way, before you're like, well, you need to rejet. This is, for whatever reason, and I'm getting ready to talk about the carburetors tested as well, this engine liked it rich. Because I tried doing it leaner. Nope, every time less power. Every time. The engine wants what it wants, not what you think the air-fuel ratio should be or none of that. So you would, like typically on pump gas, we're 13-0. It seems like it makes the best power on all the dyno time mules, everything. On this is 110 race gas because the compression ratio is 13.5 to 1. This particular build, 12.2. If you went 12.8 or 13, it lost. So I did test some carburetors, and I tested a 750 Holley XP, the Ultra XP version. I also tested the 750 ATM carburetor off my son's. Of course, the 1000 CFM Demon race Demon carburetor too. I'll show that in later videos. I just don't got time for it today. But that wasn't the only thing. This is probably the biggest thing that got tested. those. These are all spacers. I tested for the first time ever on my channel without a spacer. So I tested that same setup with a 4150 with no spacer. I'm going to go ahead and save you the suspense. The spacer always works. I've never seen a spacer lose power. I've only seen it make the same or gain. It did it again, it gained. But all of these are not just spacers. These are adapters. So this one's from Polymer Racing Products. This, by the way, was the winner, this video will be later, I promise. Because I really want to go into depth on this one because it didn't just win, it dominated. But what all these spacers they are adapters for a 4150 flange, what you saw on that circle track engine, to run a Dominator. This was the best one. But you'll see this in a later video because there's way more to it. Like how much better? Wait. This got sent in by a viewer. Thank you. If this is you, contact me so I can ship it back to you. This one has a little nub at the bottom. And then we have, this is the old style HVH adapter. This is what I've been running for all my tests before. This is part of the reason for doing this testing because this one's what I'd used. A viewer sent it in, let me use it for like a year, and then he wanted it back. Then I just finally was able to find another one this week. So here I have it now permanently. And I was like, part of the reason for wanting it back so badly is because in between I had bought this one. This is, if you order an HVH adapter now, it will look like this. There is a difference. So even if you gave them that part number, you're not going to get the old version. You're going to get this new one. And I was like, this isn't good. I know it's not good. Well, it's not, and I can prove it now. I've got dyno sheets to verify it. This was down 10 from the old one. So when they're dyno testing, it's like, oh, they're lying out the rear. It was down 10. So tested all of those. That'll be in a later video so you can see more of the results. But all these were tested. And it was interesting. So a better video later on. Plus, I'm also going to do one on the carburetors. But let me show you some other stuff that's going on beside just what I dynoed this week. While at Dunsworth, I dropped off the heads for the small block Ford Cam Challenge because I put them all together, they're assembled. Also the intake because it was finished. Dunsworth now has almost everything they needed to put the engine together, so I told them just finish it. There's like small stuff left, like a distributor, crank trigger, that's about all that's really left. I told them either order it or get with me and I'll get it coming to you. So the engine should be together and running with its baseline dyno really soon. There's one cam that I gave them to check the piston and valve clearance on, but otherwise we should be good. Speaking of which, I have everybody's cam in except for two. Joe Carroll, your cam needs to be here. Also Justin Kuntz, because the minute that engine's fired on the dyno, you need to have your cams. So I'll give a week and then we'll probably schedule a time for a week just to do all the testing, but need the cam in. Here's who's in so far, by the way, or got their cams here. Walt from B&F Engines, IMM Engines, Jacob Gibson. This is Triceratops Performance Alternate. That's not part of the competition, but we can talk about that later. Carson Kafer, Chris Allman, Keith Parks, Gerald Brand, Tyler Newberry, Tim Hillard. I had to cover up old Brent Likens because his cam card's showing. Chris Straub, P&M Performance, and John Cloud, this is actually one, and also John Batone, yours is at Dunsworth. But those are who's here. Here's what I'm going to tell you, because I told Brent Likens this today. Here's how the run order is going to go. I've already decided, because you guys don't even know this. The run order is going to go, the very first cam that goes will be the one with the smallest intake duration. And then the next cam that goes will be the one with the next smallest intake duration. The one that goes last will be the one that has the most intake duration. That's about as random as it could be, because none of you knew what each other's are. So there you go. By the way, none of you have the same, I don't think. Looking at them the other day, I don't remember. If so, I'll run them, whatever, alphabetical. They're both of them have the same, but I don't think anybody does. So at least when you're watching the live feed, you can see, well, at this duration will make a difference. However, all the exhaust durations and lobe separations are all over the map, so it probably won't make much of a difference. But at least you got that kinda as you're watching. Anyway, get your cams in. That's coming up soon. If you want to see the cam cards, I'm putting a link in the description for this video to donate to the cam challenge. Because the minute Dunsworth fires that engine on the dyno, I'm dropping all the cam cards into that file. And everybody that's donated will just click on it and all the cam card specs will be there. And you could look at everybody's cam at that point, the minute it's fired up on the dyno. So That's what's going on. Now, what about the Chevy? The small block Chevy Cam Challenge, the deadline to enter, if you want to compete, is June 1st, which is coming up. To enter, all you have to do is email me at weingartnerracing@gmail.com and tell me why you want to enter. This competition is a little bit different than the rest because there's a naturally aspirated pull, then there's a 5 pounds of boost pull, then there's about a 10 pounds of boost pull. It'll be a hydraulic roller deal, but this should be exciting. I haven't told the RPM band you're going to get to, but after June 1st, I'm going to select the competitors. I'll release all the rules, but you can kind of get an idea as it is anyway. Right now, Kuntz is building the engine as we're speaking. They got the block, the crank, the rods. They have as much stuff as the Ford actually has, with the exception of this. This is the Holley High Ram, and I finished porting it because I want to show you the inside. It's done. So if you ever look at the before, and I'll probably show the before, this is dramatically different than what it is as they come from the factory. This is the way it should be. Matter of fact, if you get the LSs, they actually look like this, which makes no sense. So they're as big as this openings are. The Chevys, somehow they made them really, really small, but this is how it is. So this should be a nice running piece. It should do really, really well with this combination, and I look forward to testing it. If you want to compete, and again, email me, weingartnerracing@gmail.com. You have till June 1st, and I'll be selecting. But anyway, this is nice, and it goes with it, and it should make this thing should make some pretty good power. This also came in, a big shout out to Wilkes Performance for this. They sent in these, the shaft rockers for the Pro Max LS3, I guess medium bore is really what they are, but heads that I have, and that's what I used in the Cam Challenge for the LS was those heads. He finally sent in a set of rockers for me to run with them. Why is this important? Because you're like, yeah, you've already got rockers that are on there and they work fine. You're right. These, though, are way beefier, and now I can run with these rockers a solid roller on that setup, because you'd have to go back in time in my channel to watch. But when I built the LS, I said I'm going to make the exact cam that was in the small block Chevy dyno mule, the 406, and I'm going to make the exact one for an LS. And I did. I had one ground up for it. Got the solid roller lifters to go with it. The only thing I didn't have was the rockers, because so now I can do a direct comparison, because I'll have the same cubic inch as what the small block Chevy was. Same compression ratio, same cam, within a few little points, nothing major. And we'll see how much of a difference the LS platform really does make as far as power-wise versus what the 406, because now this is a closer comparison. But these came in, and a big thanks to him on that, so it's a huge deal. I'm also supposed to get the actual bar for the LS3 heads, for the small bore Pro Max LS3 heads, because those have made the most power of all the heads I've tested so far, with the exception of the AFR ones, which are CNC ported and really, really expensive. So once I do that, then, because I'm really going to spice up those heads and see if I can't get that 408 LS mule I have to really make some power. But this is a huge step forward. Look how big the adjuster nuts on that thing are. That's big. I like it. I like it a lot. But anyway, on to the next. This set of heads right here are very special, because if you've been following Bob McVeigh's post on Facebook or been watching Old Man's Garage, he's been talking about this Nova that he has. Bob does, that red one. And they're building a new engine, and these are the heads that are actually going on it. So Bob had posted a picture, and he asked me to talk more about it. So what these are my Brodix Dragon Slayers, but they're my own personal design. So if you order a Dragon Slayer, it'll be literally nothing like this. So I have to order a special casting just to make this happen. But what this port is, just to kind of tell you, this is a 253cc port. And yeah, that's big. And somebody like, oh my gosh, that's too big. I don't think so. I've done a lot of testing with this, and they're fine. I have it in 2 versions. So the first version doesn't require shaft rockers. So this version does. But I have one version that you can run a stud mount rocker and a 5/16 push rod, and everything's good. You don't have to buy a shaft rocker. The version that Bob got it's moved over just a little bit, not a ton. And this one does require shaft rockers. Jesel makes a kit for it that's economical as shaft rockers can be. Scorpion currently is making a kit, and they're working on that to fit this too. But it's not anything special. If you have a Dart, like say you have a Dart Pro 1 head, and you got a shaft rocker set up with it that has at least a 300 offset, it'll fit this head. So they're the same valve spacing because this is standard valve spacing. So I didn't move the valve center lines at all in this one. So it's got a 2.125 intake valve and a 1.575 exhaust valve. Sometimes I do smaller ones, but that's what it is. You have to shrink down the exhaust valve because of the bigger intake valve. This particular set, because this is Bob's, has a 5/16 intake stem and 11/32 exhaust. However, I started switching to 8mm on them because it was getting very hard to get the 5/16 stem intake valves. The chambers, they can be milled down to 67 cc's, which is what this are. They start at 70 and then go to 67. Can't go smaller. You can tell the intake ports. And yes, it does have a wing in it. But there are a lot of options for this. So Bob didn't order on this one, but you can get the stall pattern, which I'll show you in just a second. But these are the heads that are for his Nova project. Now he's doing like a hydraulic roller, but it's pretty big cubic inch. I think it's like 421. So these will be fine. I'm not worried about the size on it at all. So I think people get too worked up on that. And if you watch enough of the last time we dynoed with a 406 and a set of 230s, these are 23 cc's bigger on 21 cubic inch bigger engine. I think it'll be fine. Not worried about it at all. It should make really good power. Plus there's plenty of room to make more power later. These flow about 330. That's what I'm going to claim because I guarantee my flow numbers. Not MBE just is not the only one I do too. But these flow about 330. So, but he also has his Camaro project. And when I was up there, I left him an almost identical set of heads just like this because something went wrong. What had happened was, I'm just going to pause this video. What had happened was I have a different set of Dragon Slayers. So actually these would be 3. This is Bob's. This is the one that, by the way, I just happened to have one on the ground. This was the one that does not require shaft rockers. So the push rod slot's different. You can kind of tell because it's got a bit of a lump right there because we move everything over to make that room, which we don't have as bad on that one. But you can kind of tell, see that little shadow there. However, the other version I make is this one. This is a 40/60 spacing and it has no port work done. Because for Bob's Camaro, the one that we were going to run was going to be this version. Because the standard valve spacings are great, but when you move the valve spacing around to a 40/60, man, they flow 10 CFM more than the rest. And they're just better. Plus the chamber ends up smaller at 63 cc's. Well, anyway, what had happened was I'd ordered these from Brodix, and it takes like 4 or 5 months to get them in. I ordered like 6 of them. One of them just happened to be a solid one that I ordered. They made that one solid, but they also made Bob's solid. So this one came in and I was like, oh crap. Because this is for Bob and it does not have a water core and he can't use that. So sucks. Yeah, it's still here. Anyway, so they're making a whole new one. I won't see one for months. But in the meantime, because I still had one at the time of these like he has for his Nova, I sent that when I was down there at Bob's, I dropped it off so he could run it on the Nova and test it so we could see. So what's going to happen is he'll run it on the Nova. And then what's going to happen is once we finally get the 40/60 one is we're going to re-dyno and we can compare the heads. We can see how much of a difference it actually makes. I got to port 2 different manifolds for it, which I need to get those done. But I got so much other customers one in front of it too. I still need to get done as well. But going to test those as well. So there's a lot going on. There is one more Dragon Slayer that I have that I'll just hint on and kind of show you this because I haven't showed his soul. But let me show you this because 40/60 is great and it's awesome, but it's not my best one. It's the best one that most people buy is not the best one. This is my best one. Its name is Big Ass, and I'm not making that up. This is Big Ass because this port's big. This one flows, and I'm not making it up. Maybe you're going to think I am, and I'm intentionally vague on a lot of the details on this head. But it's a Dragon Slayer casting, and it flows 392 CFM, and I'm not making that up. 392, and that's on the Signs bench. It flows more on the Superflow. 392 CFM. This one is so big. Like, I never even CC'd the thing, but it's huge. It's big. Big. It's just big. 392 CFM. If you're wondering, well, what's the price difference? About $8,000. So if you go from, so just to give you an idea, the cheapest one's a stud mount because I offer a little discount on that one. It's like 4,400, and it's 4,800 if you want the one that requires shaft rockers, and the 4060 spacing one is about 4,800 too. And by the way, this one has a stall pattern. You could add that, by the way, on them. This dude, about 8 grand. 8 grand. You're like, no way. Why so expensive? Because everything is custom on this one. It's a huge deal. So yeah, it's not even a raised runner. It's not a raised runner at all. It's just a Dragon Slayer. But it is badass. It took me a year developing on that, and the project kind of stalled, which is too bad. But he had a lot of money into this, and yeah, I have a program for it. But it's badass. But anyway, that's my best one. If you have to ask how much it costs, I'm going to tell you. So if you email me or call me and ask how much this thing is, you can't afford it. Just know you have to have about 10 grand to get the whole thing done. So because you still have to have the rockers and everything else. It's a 10 grand deal. So anyway, let me show you some other stuff. I'm really late about putting this out, but cylinder head abrasives. Cylinder head abrasives had sent me this to try and tell me what I thought. Well, I finally got a chance to do them. This is the one that I've been using. And this burr has been really, really great. And no, they're not paying me to say this at all, by the way. But I'm going to move my hands a little bit so hopefully I can get it to focus. This is a high helix design. Which doesn't do very good. There you go. See it over the blue? There. See the design of the flutes on that? When you have them like this, they're so much easier to control. So if you're having a problem with your grinding a head or porting a head and the burr seems like it's bouncing all around the port, these smooth it out. Not only that, they remove more material quicker. So in the way that could be good or bad, depending on how good you're doing it, bad or good at doing it. But for me, this makes things so much easier to cut material, this design. Because before, I had been using this to do chambers. And if you could tell, it's a straight, more of a straight, less of a helix. Also, the flutes are much closer together. It leaves a finer finish, but as you can tell, there's a problem as it clogs. So you have to keep using some kind of lubricant to keep that from clogging. Also, these dull faster. Now, I also use these. These are my most common one. These are like a much straighter. These bounce all over the port. So they're going to dance and tap if you don't have control. Now, I've been doing this so long, this isn't a problem. Or for you beginners, these will get you. They can get out of control. This high helix deal, much easier to control. This is the part number, by the way, for it right, find the box again, this one right here. So if you're doing chambers, I do that. If you're like, I like to get more spicy and I want to remove stuff a little bit faster, they've got a 6-tooth, the lesser groove cuts in it. And these ones will remove more material, but it's also less control. And then that's just a 8, and that's just like it as well. That's a 6. They also have them in bigger ones like this. This is just a tree one design. This wouldn't be so bad if you were doing like port matching of a manifold. Much easier to control this. I see so many people butcher manifolds because they've never used a grinder before, and they'll grab this and it dances around or digs out in corners and it just looks bad. These are more expensive because the tooling's harder to do, make helixes like that, but they're much more stable. So give cylinder head abrasives a call, and they'll be able to help you out. No, they're not paying me for any of this. And no, I don't get a commission either. I wish. You guys, on to the next. That's going to wrap it up. I'm tired of talking. Besides, you're probably tired of hearing me anyway. A couple of notes. If you're a channel member, all the stuff with like the dyno charts for the last dyno session I just did on Thursday, I'm going to drop them into your link that you have shortly. If I don't do it tonight, it probably won't happen tonight. Tomorrow morning, I'll do it as soon as I can. If you don't know what a channel membership is, it's totally different from being a subscriber. Subscriber, you just get notified of my videos. Everything that I do on the dyno itself will eventually make it into a video, but subscribers get all that stuff sent to them. So they actually get this little link, or not subscribers, but members get this little link that they can click into, and it has all the dyno sheets, and then they don't have to wait through a whole video and pause and look at stuff. If you want to be that, there's a link in the description of this video. So this video has a description. There's a link in there so you can do that. It's $150, but it lasts for a year. It's a good deal. get other benefits as well. So for instance, I was texting them while I was doing it, although I didn't get a chance to text you as much about all the changes because we were trying to keep the temperatures steady, because that circle track oil pan is big. So if it gets too hot, it stays hot and takes forever to cool down and get your oil temperatures the same. If it gets too cold, then you have to warm it back up, and that takes a while too. Then you have to deal with the water not being the same temperature. Because these spacers, I thought were going to be relatively close together, that took longer. So I didn't get a chance to text you as much. Anyway, that wraps it up. Thanks for watching. Remember, I'm no Superman. I did race Superboy. I don't port cast iron heads. You guys take care.